All right, ready? Here we go. Welcome. So now what we're going to do is we're going to talk about creating models using linear regression. And so what is linear regression? Linear regression is the process of finding the best fit line through data points. Okay, so if you have a data set and you want to describe the nature of that data set, then we would use a regression line. And so in this case, we're using a specific procedure to create the best fit line through the data, and that is called the least squares regression line, or the least squares regression. Okay, so what is least squares regression? Well, quite simply, what we do is we're interested in trying to find the deviations, right? So if you draw a line, like for example in this picture here, if you know, if we look at this picture of this line with these dots, I'm going to see if I can draw on here. No, it's not letting me draw. Anyway, if you notice on this graph here, you have the D1, D2, D3. Those are deviations. And what we're measuring is the distance from the vertical distance from the point, the data point, from the line at the same x value. Okay, so for example, if you look at D2, we want to look at the distance from Y2 to Y on the line at x2. Okay, and then same thing for D4 and D3 and D1. Those are all deviations. Now notice that some of the deviations are above the line, some of the deviations are below the line. And so what we typically do is, without getting too much into it, the least squares regression line squares all of the deviations, because some of those deviations are going to be negative and some of them are going to be positive, about half, right? If you're trying to get a line that goes right through nicely through the middle of the data set. So if we added up just all those deviations, we would get something very close to zero, which doesn't give us much information. So the least squares regression means we're going to square the deviations. We're going to add up all of the squared deviations. And then we're going to look for the regression line that makes the sum as small as possible. So we're looking for the line that minimizes the sum of the squared deviations. And that is how least squares regression works in a nutshell. Okay. And so your calculator does that already. So we're going to be using the calculator to create the least squares regression line. So creating a linear regression model begins with these steps. You got to graph the scatter plot, right? If you don't see any kind of pattern with a scatter plot, then we don't bother even considering doing a linear regression, because there's just doesn't seem to be any relationship. There's no trend. There's no pattern, right? So the reason why we do a scatter plot is so we can see the dots, so we can see the data on a graph, and then see if there's some sort of linear trend, right? Are they going up? Are they going down? What's going on here? If there is, if we do see a linear trend, then the next step is to inspect the data. Oh, that's number two. I'm sorry. So you use the scatter plot, right? So number one is create the scatter plot. Two is inspect the data visually, see if there's a trend, a linear trend. Then two, we're going to invoke the linear regression feature on the calculator and create the linear regression equation. And then what we're going to do is check the results by graphing the line with the data points. So you can plot the scatter plot on your calculator and then also graph the regression line and see it how it goes through the data at the same time. So which is really cool. So now what we're going to do is we're going to find the least squares regression line for this example. So what we're going to do is I've got a calculator here, and let me do this. Okay, so, oops, don't want that. Oh, no, come on. Okay, let's try this again. Okay, so what I'm going to do is I'm going to enter the data. So this is age versus systolic blood pressure. Okay, let me see if I can make this smaller. Okay, perfect. Now what I'm going to do is I'm going to go to Stat, and I'm going to go to Edit. Scroll down a little bit. Why? Oh. Why is it doing this? Oh, here we go. Let me. Okay. Okay, so here we go. So I'm going to go enter, and there's my table. So now I'm going to do is in L1, I'm going to type all the ages, my X data. So I'm going to do 17, 21, 27, 33, 35, 38, 43, 51, 58, 60, 64, and oops, 70. And now I'm going to go next door. I'm going to now enter the corresponding systolic blood pressure values. 110, 118, 121, 122, 118, 124, oops, 125, 130, 132, 138, 134, 142. All right, now, if you visually look at the table, you want to make sure you have the same number, the same frequency of numbers, right? So you want to make sure that the number of observations in each column are the same, which they are. We can see that here. So now what I'm going to do is I'm going to quit out of this, so second mode for quit. And now what I'm going to do is I'm going to do second. Now I'm going to go to the calc menu, and I'm going to go all the way down to 4. So I'm going to hit 4 for what? It's linear regression. And notice the form. It's going to be in the form of AX plus B, which is fine. That's what we want. And so I'm going to hit enter. And now it gives me, wait a minute, I went back. Sorry, I didn't hit 4. I just hit enter, which gave me 1. So let me quit out of this. Okay, let's do that again. So stat, calc, and now we're going to go to 4. And now notice how it defaults to L1 and L2. So X list is L1, that's our age. Y list is L2, that's our systolic blood pressure. Frequency we're not going to touch, we don't touch that. Now if we go down to store reg equation, we want to store our regression equation in the calculator. So the way we do that is when we have our cursor here, we're going to hit vars, and then we're going to go over to yvars, and then we're going to go to function, and we pick one of these values to store our equation. So let's just do y1. And so now you see y1 is listed. So now we're going to go down to calculate, and now it's going to give us our regression equation. So it gives us our y equals mx plus b, and it gives us our a value, which is our slope, and it gives us our y-intercept. But the cool thing about this is that it's under our y equals menu. So if we go to y equals, there it is. It's already stored in our calculator. So now the cool thing is we can look at the graph, right? So let's look at the plot. So how do we look at the scatter plot? We go up here to stat plot, and so I'm going to do second y equals. And now if we go up to stat plot, I'm going to hit enter for the first one. So notice that they're all off. So I want to go to the first one. And now I'm going to hit enter for one. I want to hit for on. I want it on. So now it's on. Now notice the type of graph I want. Notice it's already on scatter plot. So I'll just leave it there. And notice how it has our X list, right? And our Y list, which is good. And then it gives us we could choose different tick marks to represent the data, and we can choose a color. So I'll just leave this the way it is. And so now what I'm going to do is to graph this appropriately, because we're using real data or book data, we're going to go to Zoom, and I always use number 9, Zoom Stat, because it will automatically set the window based on the data that you put in, which is fantastic. So I'm just going to go hit 9. And now there's the data. And now look, see how it automatically graphed my regression line? That's cool. So that's how that works. Now, if we go to A, so we did all this, right? We did all this. And what's the question? So is there a question here? Let me see. Oh, it says now, D says, use the least squares regression line to approximate the systolic blood pressure for a healthy 55-year-old, round to the nearest unit. Now, the cool thing is this is how we can do it with the calculator easily. We're going to go to, see under the top here, it says calc. So we're going to go to trace. We want to hit the trace button, but we want calc. So we're going to do second trace to get to calc. And now it's going to ask you, hey, what do you want to calculate? So we want to calculate a value. So we want to find a value given an X value. So in this case here, we're given an X value, 55 years of age, and we want to find the Y value, which is the systolic blood pressure that's associated with that, according to our equation, our linear regression equation. So now I'm going to hit enter, and now all I have to do is pick the X value. So they said 55, so we're going to hit 55. Now we're going to hit enter, and there it is. See, it marks it on our regression line, and right below it says our systolic blood pressure is, now they want us to round to the nearest whole unit, so we would round to 132 milligrams of mercury. Okay, because that's what they're measured in, milligrams of mercury. And that's it. So let's see here. Is there another one? Nope, that's it. So, hey, that's how we do it with the calculator. So make sure you practice. But other than that, have a great day.